Hello dear students, today's topic is coordination compounds IUPAC nomenclature. Coordination compounds like ionic compounds have positive ions and negative ions, or they might be neutral. Example of this neutral compound is tetracarbonyl nickel. You might have seen this. Tetracarbonyl nickel is the example of neutral. So, but mostly they have either positive ions or negative ions. Now, the question is which part of the coordination compounds has coordination bond? So, in some of the compounds, for example, in this one, you can see that positive ion is the coordination entity. It is kept in the square bracket, and negative ion is the simple ion. Now in the second one, negative ion is the complex ion or coordination entity and positive ion is the simple ion. And in another example, both negative and positive ions, they contain coordination bonds. Let's see how they are named. There are some rules, we are going to discuss them now. So first is name of the positive ion is written first and negative ion is written second. Just like ionic compounds, like for example potassium chloride, potassium is written first, chloride is written second. Sodium sulfate, sodium is written first, sulfate is written second. Here also name of positive ion is written first and negative ion is written second. Second rule is while naming the coordination entity, names of the ligands are written first along with prefix di, tri, tetra, penta or hexa, which indicate the number of ligands. Central metal atom or ion is the atom or ion to which ligands donate their lone pairs of electrons. For example, in this silver complex, silver is the central metal ion. In this, iron is the central metal ion. Potassium is not the central metal ion. And if suppose this is when there is one kind of ligand present, the examples that we saw, all of them were having one kind of ligand. But if there are more than one kind of ligand, for example, in this one, this example of platinum complex, ammonia, that is AMMINE, amine, it is written as amine. It is, and spelling is not AMINE. It is AMMINE for this, and this is chlorido, right? So two ligands are present and then they have to be named alphabetically. If the name of the ligand already has di, tri, etc. in its name, for example, ethylene diamine or ethane 1,2-diamine. So di is already existing in the name of the ligand. In that case, we do not, if there are more than one ligands, we do not put di, tri, rather we put bis, tris, tetrakis in the front of the name of the ligand. Okay. Next rule is if ligand is negative, its name will end by adding O as suffix. So chlorido, okay, there is no change in the name of neutral or positive ligand, but there is change in the name of negative ligand. Chloride would be named as chlorido, cyanide would be named as cyanido. Okay. Next rule is after the name of ligand or ligands, name of central metal atom or ion is written followed by its oxidation number in Roman numerals in small bracket or parenthesis. Okay, this like this one here. So Roman numerals and parenthesis. Okay. If the coordination entity is ion, you are going to put suffix ion, okay, after the name of the coordination entity. For example, in this one, it would be first you have to write the name of the ligand along with its number, how many are present, then metal atom or ion, then oxidation number of metal atom, and one more thing, that if the coordination entity is negative, you have to end the name of the metal, central metal atom or ion by 8. So as I was discussing, first name of the ligand, second name of the metal atom or ion, along with 8 if it is negative, and followed by oxidation number and ion. Now what is the difference between naming this and this? In this is ion form, right? So we would end it by writing ion. After the name we are going to write an ion, while in this you are going to name this positive ion first, as we discussed earlier. Then you are going to name this coordination entity, and you are not going to put any ion after the name of the coordination entity. We are going to take some examples so that this is clearer. Okay, if there is an ambidentate ligand present, then the name of that ligand is followed by symbol of the atom that is donating the lone pairs of electrons. For example, in this one, this is thiocyanate ion, right? So it would end, because S is the donating atom, it would end by writing S after thiocyanate. I hope the rules are clear. Okay. Now let's do a few examples. So let's take up the example which we have been doing since the beginning of the video, this one. So how to name this? First name the positive part, potassium, and then name the second, which is coordination entity. Here the name of this coordination entity would follow this. So potassium hexacyanidopherrate. We would calculate the oxidation number of iron, which comes out to be 2. Okay, so potassium hexacyanidopherrate 2. I am not putting iron because we are just not naming this, but we are naming full compound. Okay, which you can see the comparison here. Okay, next is hexaamine AMM. Hexaamine iron 2 ion. Next, hexaamine iron 2. Now here I had kept iron, but then it has reacted with chloride, so iron is replaced by chloride. Hexaamine iron 2 chloride. Next, in this there are 2 ligands, so we are going to follow alphabetical order. Here this is chloridoethane 1,2-diamine. So we are going to name this chlorido first, therefore name would be dichlorido bis, because in the name there is di. So dichlorido bis ethane 1,2-diamine cobalt 3 ion. Next, tetracarbonyl nickel 0. Next, potassium trioxylato chromate 3. And last example in this video is mercurous or mercury 1 tetra thiocyanato S cobaltate 3. I hope this video was helpful for you to understand the nomenclature of coordination compounds. So practice some more so that you can eliminate mistakes, and I would be coming with a new video very soon. Till then, take care. Bye bye.